Okay, so we have question 2253 from your text from Summer. I have some of the answers written up on the board, which we'll go through, and then I'll have to record the others as a separate video. The first, A, only has two different types of, or two positions. Both of those positions are identical to each other. So it doesn't matter at all where these are directing because they're only the one type of position. When we're trying to add on this type of group where we have the carbonyl, this is straightforward acylation. So all we need to do is deliver an acyl group on a chloride or a bromide. I tend to use chloride because that's most of the examples we've talked about in class. And so we use the same group but with a chlorine instead of the aromatic ring. When we use that chlorine at that location, we need some sort of catalyst to activate it. So aluminum trichloride is the standard catalyst for that reaction. So this would be a straight example of a Friedel-Crafts acylation in this reaction. The next reaction, we have three nitros, but they're spaced so that every group around them is identical. So again, there's no need to worry about the direct-in effects of the nitros in this example. The reaction involves putting on a bromine, and so we're doing a standard electrophilic bromination. We use a Br2 as the source of the positive bromine. We make it more positive using some sort of usually iron-based catalyst, like iron metal or FeBr3. The next reaction is a sulfonation. Again, every one of these positions is identical, and so all we need to do is supply the conditions for the sulfonation, in this case H2SO4. You can add SO3, that sometimes makes the reaction go a little bit faster. This reaction otherwise is just concentrated sulfuric acid. For D, we have, again, two identical positions. They're both between a bromine and a chlorine, and so again, the conditions are just whatever we need to install the NO2 group on this ring. The conditions for installing an NO2 are the nitration conditions, which are nitric acid concentrated and sulfuric acid that's catalytic.